constant velocity problems. In this lesson, we're talking about how to deal with constant velocity problems. So basically, using vector equations and real world problems. So first thing I do a little vocab. If an object has an initial position vector A, so initial position vector just means like that's the way you're moving right now. Like you're swimming on a path, and that's the direction you're swimming initially. And then it moves with a constant velocity B, so that's something like a current pushes you this way. Its position at given time r, so you want to find the position at any point, is just given by the vector equation, the normal vector equation. So it's this initial position vector plus how long you've been going this direction, or that thing's been pushing you. Now here's the vocab though. Speed of an object is just a magnitude of the direction vector. Right? Again, when we have this equation, the direction vector is the king, this thing we care about the most. So if you want the speed of the object, it's just what's the size of this direction vector. So you just take the magnitude of it. So let's do an example. So here's our vector equation. So that tells us the path of an object. Find the object's initial position. Well, you could plug in 0 if you wanted to. But that's really all it's going to do is get you this point right here, my initial point. So my initial position is going to be 1, 9. Actually, my initial position should be a point, so 1, 9. Right, little details, right? 1, 9 like this is a vector. Position should be a point, so 1, 9, the point 1, 9. Plot the path of the object at t equals 0, 1, 2, 3. So they just want you to plug in 0, 1, 2, 3 and see what's going on. So we'll do a basic graph here. At that, if I plug in 0, I get 1, 9. So 1, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I plug in 1, I'm just going to do this off air. So let's plug in 1. You get 3 plus 1 is 4, and then 5. So 4, 5 for this guy. So 2, 3, 4, 4 and 5-ish. If I plugged in 2, it would be 2 times 3 is 6, 6 plus 1 is 7, and negative 8 plus 1 is 9, so 7, 1. Just like that. If I plugged in 3, I would get 9, 9 plus 1 is 10, and then 3 is 12 minus 3. So 10 and negative 3 would be my next point. So like that, just get you a sketch. So it's kind of going in this direction. So that's the path of the object. This is B. So that's the path of the object for 0, 1, 2, 3, right? Just plug in 0, plug in 1, plug in 2, plug in 3, plot the points. Find the velocity vector of the object. Well, that's another easy one, right? Velocity vector, that's its definition. Velocity vector is this guy. So the velocity vector, notice it said vector, so I'm writing it as a vector. So 3, negative 4. If I want, I could write it as also this way. But that's your velocity vector, right? Notice it's a vector, not a point like the initial position. Find the object's speed. So that's a new definition, right? That's just the magnitude of the velocity vector. So the speed of the object would be the magnitude of this guy. So 3 squared plus negative 4 squared. I get radical 9 plus 16, or radical 25, which is just 5. So the speed of this object is going like 5 miles per hour or something like that. The speed is 5. If the object continues in the same direction but increases its speed to 30 meters per second, say its new velocity vector. So what's going on here is this. Our current velocity vector is this guy, 3, negative 4, from up there. But we know this has a value of 5, right? We just figured out the velocity of this guy is 5. I want a velocity of 30. So how do you go from 5 to 30? Well, you multiply it by 6. That's all we have to do. So just multiply this guy by 6. So you're going to get the velocity vector of 12, 18, I can do math, 18, and negative 24. That's my new velocity vector. So we're going to go like 6 times the speed if we use that velocity vector. Now notice how it said the same direction, so that's why I did that one. If it said the opposite direction, I just multiply by negative 6. Same idea. So the next example here. The object is initially at 510. It moves with the velocity vector 3i minus j meters per minute. Find the position of the object at time t. So this right here just means basically what's the formula. That's all it wants to know. What's the formula? Because it's at time t, so it doesn't want a value to set. What's the formula in general? So we know our formula. R equals a plus tb. So my formula is going to be R equals my initial point, 510, my initial vector I should say, plus t times my velocity vector. Now again, this is another way of just writing 3 and negative 1. And there we go. Now sometimes they might want that as a point. If you want a point, then you just separate it, right? My x values, like this would just be my x and my y, right? Honestly, right? So my x point would be 5 plus 3t. My y point should be 10 minus t. So you can also write it that way. I guess this way I probably should because it's position. So it's usually a point. So I'd write it like that as a point. Let's find the speed of the object, b. Well, the speed I was talking about is it's the magnitude of the direction vector, which is my direction vector is just this guy right there. So 3 squared plus negative 1 squared, which gets me radical 9 plus 1, or rad 10. Let's see the position of the object at t equals 3 minutes. So all we're going to do is go back to my equation here and plug in 3. Or actually, since I wrote it like this, I could plug in 3 here. Either way is fine. Let's use this since it's already as a point. So this be 5 plus 3 times 3. The one at 3 minutes. And then 10 minus 3. So 5 plus 6, 7. I get 11 and 7. That's the position of the particle after 3 minutes. Again, I can also sub it into here and get the same answer. The time when the object is due east of 0, 0. So what's going on there is it's due east. So that means it's going, like if we had an XY chart, it's going this way. Well, in that case, your y equals 0 because it's going due east. You haven't moved on your extra y. So we're gonna get our equation up here and set the y equal to 0. So to be 0 equals 10 plus negative t, right? Just using that line there, or using my y right here. And if I just add t to both sides, I get t equals 10. So at 10 minutes, it's due east. That's it.